Hello there, welcome to another video on GD&T. In this video, we'll be exploring about composite position tolerance. What exactly is it? How is it different from the traditional position control in GD&T? And where to use these kind of composite position controls in drawings. So here is an example of a block as shown over here in the 3D view. So there are two drawings shown over here for the same block. One is without composite position control and one is with composite position control. On the left hand side is the normal traditional way of controlling the position of the two holes. So basically that is a datum scheme. The datum feature A is this surface, the large surface datum feature A. Datum B is a surface at the bottom as shown, bottom surface of this block. Datum feature C is the side surface, this surface of the block. And then the holes are being controlled with respect to their position within a cylindrical tolerance zone of 2 mm with respect to datum A, B and C. So A, B, C form a datum reference frame and the position is being controlled of the two holes which are as a pattern within that tolerance zone of 2. The size of the holes is 25 plus or minus 0.1 and the basic dimensions are provided originating from the datum feature B. So this hole is located at 25 and the interhole distance is 40. So these are the basic dimensions. And then there are other dimensions given for the width, which is 60 plus or minus 0.5 and 20 plus or minus 0.2 of the part. Now this is normal position control, which this means that the position of the individual hole should not vary beyond a tolerance zone of 2 mm, a cylindrical tolerance zone of 2 mm. In 2D, it is circle. So within a diameter, within a circle of diameter 2, the axis of the hole should not vary beyond that. That is the meaning of this control. Now, in composite position tolerance, when we are having a second line in the position control like this, and then there is a tolerance value mentioned, it means that we are controlling the pattern in the first line and controlling the individual features in the second line. So the first line says that the pattern over here is nothing but 2 points which are spaced by distance of 40. That pattern by basic 40, that pattern, that line should lie, the ends of the line, that is the 2 points which indicate the two axes of the two holes, should lie within a tolerance zone of 2 mm, that is this tolerance zone as a pattern, and individually the individual features with relative to each other should lie within a tolerance zone of 1. So there are two tolerance zones. One is the pattern locating tolerance zone, the larger tolerance zone which locates the pattern with respect to the datum reference frame. So the pattern over here is a single line which are having 2 points, and this pattern is being located as a whole with respect to datum reference frame, and the second line is locating the relative position of one hole to the other. It is a feature locating tolerance zone. So the second line is locating one hole with respect to the other, which means that as a pattern, the two holes can vary within a tolerance zone of 2. But when it comes to the relative distance between the two holes, they should not vary beyond the tolerance zone of 1. That is the meaning when we are using composite position control. First line is controlling the pattern as a whole. So over here there are two holes. So the pattern is a single line connecting the two axes of the holes. If it is a rectangular pattern, it means that there are 4 holes. That pattern as a whole can vary within that tolerance zone, whereas the individual features, the relative position of the individual features with respect to each other is being controlled in the second line. So it is a feature locating tolerance zone. So first one is the pattern locating tolerance zone. The larger one, the feature locating tolerance zone, is the second one. Always the feature locating tolerance zone should be smaller than the pattern locating tolerance zone. That is the meaning. To visualize this, here is a graphic which shows the movement of the smaller tolerance zone inside the larger tolerance zone, which means that the feature locating tolerance zone, which is of dia 1, can move around the pattern locating tolerance zone of dia 2. So the pattern locating tolerance zone is fixed with respect to the datum reference frame, whereas the feature locating tolerance zone is relative to the position of the hole, the actual position of the hole, which means that the feature locating tolerance zone, the smaller tolerance zone, can move around but it can only move around inside the larger tolerance zone, which is the pattern locating tolerance zone. So the pattern is located based on the first line, whereas the hole to hole distance or the hole to hole position is controlled by the second line. So this is a very, very important concept to learn in composite position control. The main reason why composite position control is used is because of this feature, that we are able to control, or we are able to control in a more refined way, the distance between the two holes, the relative distance between the two holes.